Imagine you are sitting in a cafe, watching people passing by outside. One person passes by quickly, another moves slowly, and just for a moment, a strange feeling comes over you. The feeling that time is not the same for everyone, as if some people are living in a slightly faster version of today, while others are passing through a slower one. You shake it off. It's probably nothing. But what if it is something? What if that strange feeling actually points to something real? Something physicists discovered a long time ago, but that we never truly stopped to think about. Here is the thing. Time does not work the way we assume. We grew up thinking of it like a river. One way, one speed, the same for everyone. You wake up, the clock ticks, the day progresses. This feels solid, even obvious. But this picture is wrong. Not metaphorically, truly, physically wrong. The first crack in this idea came from Einstein, not from a laboratory experiment, not from a machine, but from him just sitting and thinking deeply about what it would look like if you chased after light. And what he reached was deeply disturbing. If the speed of light is the same for everyone, no matter how fast you are moving, then for this to work, time itself must bend. It cannot remain constant. Something has to have a margin of flexibility, and that thing is time. So let's look at what this actually means. The faster you move in space, the slower you progress in time. Not as a feeling, not as a perception. In a real sense, physically slow. At the speeds we move in daily life, this difference is so small that it is almost impossible to detect. But as you approach the speed of light, the effect reaches extremes. Time doesn't just slow down a little, it almost stops. For a long time, this was just a prediction, elegant mathematics on paper, nothing more. But in the 1970s, physicists decided to actually test this. They took atomic clocks, the most precise time-measuring devices ever made, accurate to a billionth of a second, and they placed them on commercial airplanes flying around the world. Other identical clocks remained on the ground. When the planes landed and the clocks were compared, the clocks that had been in the air were slightly behind. Very little. We are talking about nanoseconds, but the difference was real, consistent, and exactly matched what Einstein's equations had predicted decades ago. This experiment is known as the Hafele-Keating experiment, and it didn't just confirm a theory, it confirmed that time itself passed differently for those clocks. The clocks in the air truly ticked slower. In the truest sense, they aged less. And this is not a curious detail sitting in a physics book. We live with its consequences every day. GPS. Satellites orbiting the Earth move fast enough and are in a different enough gravitational environment that the clocks inside them drift relative to our clocks on the ground. Engineers have to constantly correct this, taking into account both the speed effect and the gravity effect. If they didn't, your navigation app would drift by kilometers within hours. Time dilation is not a theory we are still discussing. It is an engineering problem we have already solved. Therefore, when people ask if time travel is possible, the honest answer is we are already doing a version of it. Progressing through time faster than normal is a real and proven thing. The clocks on the planes didn't just seem to tick slower, they really did. They experienced fewer seconds than the ones on the ground. This is not a metaphor. This is what happened. But here we come to a more complicated place. Because while going forward in time is real and measurable, going backward is a whole different story. There is nothing in mathematics that strictly forbids the past. That's what is strange. There are real solutions in Einstein's equations, real solutions that look like paths leading back to themselves within space-time. Physicists call these closed time-like curves. These too are technically not science fiction. They are just deeply, deeply weird. And once you start following them to their logical conclusions, things get uncomfortable very quickly. You've probably heard the classic version. You go back to the past and accidentally prevent your parents from meeting. Now, you were never born. But if you were never born, you couldn't have gone back. You couldn't have prevented your parents from meeting, so did this happen or not? This paradox doesn't just melt your brain. It points to a real tension in physics. Either the universe has a built-in mechanism that prevents these kinds of loops, or reality is much stranger than we imagined, with branching versions that never intersect. Stephen Hawking actually proposed something he called the chronology protection conjecture. The idea was this: the universe fundamentally does not allow closed time loops to form. Nature itself establishes a kind of balance to keep the timeline consistent. He put this forward not as a proven law, but as an educated guess. He meant that even if mathematics seems to allow it, something always intervenes. And then there is the energy problem. Paradoxes aside, the space-time curvature you would need to bend time backward requires energy on a scale that, in practical terms, does not exist. Not just in the sense of we don't have the technology yet. It's more like this. The numbers involved make the total energy output of the sun look modest. So where are we really? Progressing through time faster than normal is real and proven. Going backward, however, hits mathematical, physical, or entirely different kinds of walls. Something about the nature of causality that we don't yet fully understand. What takes this beyond an abstract puzzle is that it constantly returns to the bigger question of what time actually is. Not how we measure it, not how it feels, but what is beneath it all. In reality, is it a dimension we pass through like space? Or is it something that exists only because things change? Would there be no time if there were no change? Physicists haven't settled this. Philosophers haven't agreed either. There is one group that says time is fundamental, woven into the fabric of reality, and another group that says time is almost an illusion. Something that emerges from the processing of information and does not exist on its own. That cafe you were sitting in at the beginning, the window, the people passing by, that strange spark of a feeling. Time was doing something there too, quietly in the background. The clock of the person moving fast was ticking differently from the clock of the person standing still, by a tiny margin, but differently. Not enough to notice, not enough to care, but different nonetheless. In a sense, we are all time travelers, just very, very slow ones. And the question of whether we can go faster or backward is still one of the truly open ones. Not because we haven't thought about it enough, but because the universe, so far, has not decided to fully show us. If this is the kind of question you've always had in the back of your mind, but never quite looked into, there are plenty more where that came from. Subscribe and let's keep going.